From Launch Complex 41 at Cape Canaveral in Florida, this is Atlas Launch Control at T-minus 2 hours and holding. The countdown clock entered a planned 30-minute built-in hold approximately 6 minutes ago, and we're now just over 2.5 hours away from the liftoff of NASA's TDRS Tracking and Data Relay satellite. Launches atop a United Launch Alliance Atlas V rocket from Complex 41 at Cape Canaveral. The launch window today extends from 9:05 to 9:45 p.m., a duration of 40 minutes. This will be the 43rd Atlas V launch. Of those, TDRS-L will be the 11th NASA mission to launch on an Atlas V rocket. We also just completed a weather briefing with Clay Flynn, our launch weather officer from the 45th Weather Squadron, and the conditions remain generally favorable, with just a 10% chance of not meeting our launch weather criteria. Currently at the launch pad, the temperature is 55 degrees, with winds from the north 5 to 8 knots. At launch time, the winds will be from the north 10 to 15 knots. The temperature will be 46 to 47 degrees, visibility 7 miles or greater, with scattered clouds. And right now there are no weather constraints toward a launch tonight, other than the possibility of some thick clouds from the north from an approaching front. Otherwise, good conditions for launch tonight. Looking aloft, no shears observed currently. The highest wind is at 45,000 feet and 105 knots. We're going to look now at some video of the rollout of the Atlas V rocket with the TDRS spacecraft, which occurred on yesterday morning at about 10:22 a.m. Atlas V has a 14-foot diameter fairing for this mission, and with that has an overall height of 192 feet for the rocket. The Atlas V liftoff weight will be 746,061 pounds. Of that, TDRS-L fully fueled for flight will be just over 7,600 pounds. The Atlas stage by itself is 106.5 feet long, 12.5 feet in diameter, burns liquid oxygen and RP-1 fuel, along with liquid oxygen. During our launch tonight, it'll burn just over 4 minutes before the Centaur stage fires. The Centaur is 41.5 feet long, 10 feet in diameter, burns liquid hydrogen and liquid oxygen. First burn of the Centaur will last 14 minutes and 12 seconds, and the second burn 1 minute 59 seconds. And at that point, the TDRS spacecraft will be ready for spacecraft separation. At this time, all of our launch preparations continue to go smoothly. We're still targeting a 9:05 p.m. liftoff tonight. At T-minus 2 hours and holding, this is Atlas Launch Control. This is Atlas Launch Control at T-minus 2 hours and holding. Our countdown continues to go smoothly, targeting a 9:05 p.m. launch. And joining us now here in the broadcast booth at the Atlas Space Flight Operations Center is Greg Williams from NASA headquarters. He is the Deputy Associate Administrator for Policy and Plans for Human Exploration. And Greg would like to welcome you very much, and you can give us a little bit of discussion about the role that TDRS has played and is playing now and is going to play, because it's rather important for our future space exploration plans.
Yes, indeed.
Let's go ahead and roll that, and Greg, if you can kind of tell us what it is that we're seeing as we go along.
Sure. TDRS is part of our Space Communications Navigation Program. As you can see, from the early days of space exploration, the 50s, 60s, even into the 70s, we were totally reliant on ground stations to communicate with our Earth orbiting and deep space spacecraft. And while that was fine for the early things we wanted to accomplish, it really only gave us coverage about 10 or 20% of the time. And we really needed to get to a place where we could have continuous coverage to really guarantee that we can control a spacecraft, operate them safely, and return the data from the Earth. In the 80s, we began launching the TDRS spacecraft, and what that really gave us was line of sight continuously for the Earth orbiting spacecraft that you can see here. We control the International Space Station in terms of telemetry and commanding, and also receive data back down to the Earth from the space station, keep our crews safe and productive. Also, the Hubble Space Telescope, which is locking secrets of the farthest distance of the universe, communicates to the Earth through the TDRS space network and the ground station associated with it. Similarly, the Earth observing satellites, for which we get so much data on climate change and weather and natural hazards prediction, comes again through the TDRS space network. And we're really seeing now is us being able to communicate through the TDRS antennas, that data streaming down in hundreds of megabits per second to the ground stations in Guam, which is then redistributed through White Sands. As we move into the future, where we really want to get to is laser communication. As you can see, we've already demonstrated laser comm from the LADEE spacecraft in orbit around the moon. And what this allows us to do is be able to move away from, eventually, radio frequency dependence and into laser communication, where we can transmit enormous quantities of data from enormous distances in deep space. As you can imagine, a narrow laser beam acquiring a spacecraft at the distance of the moon or even farther is quite an exercise in pointing and acquisition. And yet we've been able to accomplish this and demonstrate we can with the laser comm demonstration on the LADEE spacecraft in orbit around the moon.
So how do we see the demand for the TDRS capability? There's obviously just tremendous quantities of data that have a requirement now to come back, and with Space Station and Hubble and now other spacecraft that have great data requirements, are we capable with enough spacecraft, TDRS spacecraft, to be able to handle even all that we've got coming in the near term?
We are. TDRS allows us to do that. This is the third generation of TDRS satellites that is being launched. TDRS K last year, TDRS L this year. And these are going to give us that capability well into the mid-2020s. We have, as you indicated, enormous quantities of data coming back from Hubble Space Telescope, from the Earth observing satellites, from the space station, and TDRS really gives us continuous contact and communication with all of those assets.
Well, Greg, thank you very much, and we're looking forward to not just the launch tonight, but all of the capability that this is going to be giving us going forward, even in the near term. So thanks very much.
You're welcome.
And we're still at T-minus 2 hours and holding. We'll be coming out of the planned hold very shortly. This is Atlas Launch Control. This is Atlas Launch Control, T-minus 2 hours in holding. In preparation for coming out of this planned built-in hold, we'll be listening to our NASA Launch Director Tim Dunn polling his team for a readiness to come out of the hold. This is Atlas Launch Control.
And attention all stations, this is the NLM on the NLM net, ready to conduct the cryo tanking poll. Current status for today's launch attempt, we have a good vehicle, currently working, no issues. We have a clean range. We have good range instrumentation at this time, and we have a healthy spacecraft. So with that, I'd like to begin the cryo tanking poll with NASA CE.
NASA CE, go.
SMA.
SMA's go.
SMD.
SMD's go.
NASA MEM.
NASA MEM is go.
NAM.
NAM is ready.